on Physics SPM Trial 2021 Sarawak Paper 1. Let's look at questions 1. Questions 1 is from Chapter 1 Measurement. So which of the following quantity is not basic quantity? As you all know, there is only 7 base quantity, and then the rest of those quantity, right, will be derived quantity, right? We call them as derived quantities. So therefore, we see what are the 7 base quantity first. So the 7 base quantity is refer to length, time, electric current, then mass, temperatures, amount of substance, and also luminous intensity. Yeah. So if you look at all the options, okay, they want the one that not. Since length, time, electric current, they are basic. So this 3 is not the answer. So the only answer showing here, which are not from all these 7, is quantity of charge. So hence the answer will be D lah. Okay, so for question 2, diagram 2 shows situation in the playground. So this is the conversations, right? And they ask what is the suitable manipulated variable and responding variable. Okay, the two swinging at different speed. What is the reason? And let us carry out a scientific investigation. So if you to be observant, why they are swinging at different speed? Why? Okay, because you look at the length of the swing. Okay, so this is shorter, this is longer. Okay, so hence the manipulated variable will be actually the quantity for length idea. Okay, and what you're going to investigate, you want to get the period of oscillation which represent the responding variable. So hence the answer will be B. Question 3 is from 4 chapter 2 forces and motion, linear motions. So diagram 3 show the path traveled by a man. And what is the quantity can be determined from path PQR and also PR. So of course, you all need to remember back the concept of scalar quantity and also vector quantity. So scalar quantity is quantity which have magnitude only. This means you have the value will do. But then vector is which is the quantity which has both direction and also magnitude, which means the idea of direction is important in this context. So therefore, if you all recall back under scalar, you have those quantity which is like distance. Well, vector is actually displacement. Then the idea of speed is actually scalar, but velocity is vector, right? Sorry, the speed. So hence, as you all notice, if they have direction, the definition for this displacement is actually shortest path from initial to final point. So that's why PR, that straight away, right, is shortest compared to PQR. Because PQR, they actually do not involve the idea of direction. So that's why they classify at distance. Okay, and speed is actually distance over time. Or rate of distance. So therefore, they are same idea that whereby you can get the info from PQR. Hence, displacement speed is from PR. So again, we see the option. So PQR should have distance and also speed. Distance and speed, these two cannot. While PR should be displacement and velocity. So hence the option is A lah. Questions 4. Diagram 4 show an aeroplane is take off. How long must a runway be for an aeroplane to reach take off velocity 75 meter per second, if it can accelerate 2 meter per second. So this one you will involve the equation of linear motion. Okay, so again, you need to find out what is the quantity given in the questions. So giving you this velocity is referred to initial velocity, and then you also have, the initial velocity must be 0 because you need to take off. If you want to take off, that means your u should be 0, but then you will reach a final velocity of 75. And then this is your acceleration, and they actually want to know how long. How long means the idea of displacement. So basically you have 4 formula. If you all remember, v equals to u plus at, and then you have s equals to half u plus v times t. You also have s equals to ut plus half at squared. And lastly, you have v squared equals to u squared plus 2as. So how do you actually apply this 4 formula? You're actually finding the one that not involved. By right, you're supposed to have 5 unknown, which is u, v, a, s, and also t. So if you look at here, which is missing, like this one, they do not have the quantity for displacement. This one, they do not have the quantity for acceleration. This one is v, while this one is time. So you see, you have s, a, u, v, missing what? Missing t, right? That's why this is the formula we choose. So once you choose the correct formula, right, then you can sub into the equation and get the answer lah. So you have v 75 squared plus 0 plus 2 a. S is unknown, that's why you remain a. You have the value which is 2. Then you expand the equation of 5625 will be equals to big 4s, and s is 1406.25. So it's about 1400 among the answer, or C is the most accurate one. Number 5, diagram 5 shows ball A and ball B have different masses. One ball having the mass twice the other ball. Without lifting and weighing, how do you determine which ball has greater mass? So as you all know, the quantity of mass, you can always relate with the idea of inertia. So what is the concept inertia? Tendency of an object to resist change in motion. If they have higher mass, that means they will have higher inertia. That means if the object is heavier, it's actually much more difficult to move and also much more difficult to stop as well. So push the ball with same force. The ball that harder to move have greater mass, correct? Because they have greater inertia. So basically we have A, but then sometimes you must also go through B, C, D to see is other option are more accurate or better choice or not. So this is the idea of objective. Sometimes they actually seems okay, but not necessarily the best answer. Okay, so we read B also. Move both ball with same force. The ball with having greater acceleration have greater mass. No, because higher acceleration means lower mass. If heavy, then you will accelerate slower. Okay, next, rotate both ball. The ball will quickly stop, have greater mass. Also not correct, because by right, if they stop faster, that means it have lower mass again. Lower mass. Then move both ball on the flat floor. A ball moving straight have a greater mass. Also not a correct idea. So the choice memang is A lah. Okay, number 6. Diagram 6 show follow through action by a football player. So what is the purpose of follow through? So follow through means you move from a higher distance, then only you kick. So you see his leg is at a higher position. Higher position. Then later on you move, or you like swing the golf club. Same thing, you swing the golf club. Okay, so you swing it down. So this action is called follow through. So the idea is basically to increase the impulse. So what is mean by impulse already? Impulse is actually the product of force times time. So when you move with a longer distance, you're actually increasing the time taken. So when you're increasing the time taken, you're actually increasing the impulse itself. Okay. Okay, not impulsive force, because impulsive force is rate of change of momentum. If you to do that, then your force is less, so this is not what we want. But then the moment we hit those objects, the moment the touching time is supposed to be short, but then not under the idea of follow through. Follow through is the moment that you move or swinging from high point to lower point. Okay, so don't mix up with the idea of impulsive force. Then increase the inertia, also not correct. Decrease the chain, also not correct. Number 7 is from Gravitations. A radar image satellite orbit around the Earth at the height of 500 km. What is the value of gravitational acceleration at the position of the satellite? Okay, so for these questions, you need to know what is the formula used for calculation. They want to calculate gravitational acceleration. Okay, and the formula we're using is G equals to capital G M over R squared, where G is gravitational constant, and then mass is referred to mass of Earth, right? So, but in this case, if I were to sketch out the idea, this is your Earth, okay, and then let's say the satellite at certain, this satellite, height, they give you the height only, right? But bear in mind, what is this R? This R is referred to the distance from center from here to here. Okay, that means you also need to take into account of the idea of the radius of Earth. So hence your equation will become Gm over bracket R plus H square. Then when you sub inside all the value, I always tell students, make sure everything is in SI unit. So value of G 6.67 times 10 power of negative 11, no problem. The mass is in kg, also no problem. But then if you were to look at the idea of height later on, you need to be alert. You see now, your radius is in meter, right? No problem. But your height is in kilometer. So what does kilo mean? Kilo is 10 power of 3 or 1,000. So you time it 1,000. Clear? Then bracket and then square. Yeah. So if you always worried you will press calculator wrongly when you press everything one shot, right? You may actually like get the answer for the top part first. You find out this first. Then only you divide the one at the below. Okay. But then if your calculator memang have the ratio form 1 division, it's okay to put in everything. Because you can look at the power, all this you have. But if you or you press a few times, because normally those equation that have square, all these student will always have the tendency to press wrongly lah. So hence you get 8.44 meter per second per second. So the answer is D. Questions 8. Diagram 8 shows some planet in solar system, and then from the diagram, what is the conclusion that can be made? Okay, so they are showing you that for Mercury, they are using 0.2 years, and then Jupiter's 11.9 years. So the time here is actually the orbital period here. This is called orbital period. So as you can see that why the orbital period is different for different planet is basically the distance from, you see the Jupiter from the sun, okay, and then you look at the Mercury from the sun. So if they are shorter distance, then they are shorter time, notice or not? And then if the distance is further, then they take longer time to complete a cycle. Okay, so that's why you see the time is from 0.2 years to 0.6 and then 1 and then 1.9 and then 11.9. So actually this is under Kepler's third law idea, Kepler's third law. So what does Kepler third law state that they memang have this relationship one. It's saying that the cube of the radius is directly proportional to the square of the orbital period. So you find which statement is more accurate one. Okay, you see the radius of orbits is directly with orbital period. So they do not have the cube and square. So that's why it's not accurate. The square of radius is directly proportional to cube of period. Also wrong, ma. It's supposed to be cube of radius. The greater the size, the greater the orbital period. Not accurate. Okay, it's nothing to do with size. Nothing to do with size. And then the cube of the radius orbit is directly proportional to the square. Yes, so that's why the answer is D. Okay, number 9, which of the following statements are correct about geostationary satellite? So for your understanding, geostationary satellite, the applications is also for the idea of communication, for telecommunications lah, like your watch any live like football, all this, right? Yeah, so you will use those satellite which is geostationary one, and then you have another classification of satellite which is called non-geostationary. Okay, for so for non-geostationary, normally they will more focus on this GPS, and then you have imaging. That's why it will always be changes, you change direction, like you go where and where. Okay, but then for this communication or geostationary satellite, their feature is you must always at the fixed position one, so that the observer is stationary, to be stationary. So they exactly will orbit same time at Earth one. So that's why their orbital period should be 24 hours. Okay, and then same geography locations. So this one not correct because it's for geostationary. Then the direction that must be always the same as the Earth rotation. Okay, hence the choice 1, 2, and 4, and the answer is B. Okay, number 10 is under the idea of specific capacity. Diagram 10 show a boy walking on the sand and another boy walking in the sea. Which of the statement can explain the situation given? Wow, the sand is hot. Okay, but the sand, the sea water is cold. So why seawater is cold, but then the sand is hot? Okay, so it's basically based on the specific heat capacity for both material is different. Okay, so the short form for specific heat capacity is C. So sand will actually have lower specific heat capacity, but this C will have higher specific heat capacity, whereby any object that have low specific capacity, they absorb a little bit of heat, then they can increase its temperature a lot, because the definition of specific capacity is what? The heat needed to increase the temperature of 1 kg of substance by 1 degree Celsius. So because the seawater, the value is big, that means they need to absorb a large amount of heat, then only it can increase its temperature. So if we compare to the sand, that's why sand will be heat up quickly. Heat up quickly. Okay, so they should only compare the specific capacity for both quantity lah. So this one, they say specific capacity lower than the specific latent heat, so not correct. Okay, so for your understanding also, what is latent heat? Latent heat is the heat needed to change the state of an object. Let's say you change from ice to water, right? So it's actually from solid to liquid without change in temperature. So it's another concept. So nothing to do with these questions lah. So if it is the idea of latent heat, okay? Okay, so the answer is D, as the specific capacity, like they just say, is lower, smaller compared to seawater. Next, diagram 11 show alcohol is blown repeatedly by using a drinking straw, and it is found that the outside of the beaker become cold. Which of the following statement is correct? Okay, first, as you all know, the liquid alcohol, they have low boiling point. So the action of blowing is to make the liquid even cooler. So what happened is basically why there is outside there is water because condensation occurs the water is caused by condensation. That means the idea is there is a change in state of the idea of the substance, that's why condensation occur. So in this context, latent heat will be involved. Latent heat is the heat that is changes its state without change in temperature. So the answer, let's see, A, absorption of heat capacity during evaporation give cooling effects. No. Okay, the evaporation occurs inside the beaker. But then they will cause the condensation idea because cooling effect so that's why there's also water outside. Okay, so absorption during evaporations give cooling effect. Yes, B. That's why they're cooling so outside condense. Okay, then C, low specific capacity. No, not so accurate. They want to explain the idea of the cooling effect. So the answer is B. Question 12. Diagram 12.1, 12.2 show two identical strings with their nozzle closed. So when the volume of air trapped in the string is 3 ml, the pressure is 1 times 10 power of 5 Pascal. Then when it's pushed slowly, it becomes 0.45. So where is the pressure in trapped air? So the idea of 3 ml, 0.4 ml is actually the idea of volume, correct now? Okay, so this is V1, V2 lah. So there is actually changes in the concept of pressure, correct? Yeah, so pressure and volume is actually what law and what formula can you be used? So actually, this is under the idea of gas law. Remember the triangle PVT, right? So basically, quantity for PV is the idea. You see, Guru, Passer, China for the three side. Okay, so G is referred to Gay-Lussac's law. This one is referred to Boyle's law. And then this one is Charles' law. So we are involving the idea of PV, so involving Boyle's law. And why do you use this triangle is you can get the formula straight away also. So do you notice P and V, they are side by side. So the formula that we are using for calculation is P1 V1 equals to P2 V2. Like Gay-Lussac law, Charles' law, if they ask you for calculation, then you see they are up and down, right? So Gay-Lussac is P1 over T1 equals to P2 over T2. Charles V1 over T1 equals to V2 over T2. But then whenever you calculate Gay-Lussac law and also Charles' law, right, the temperature must be absolute temperature. You need to plus 273 to change to Kelvin one. But now this question we focus on this, so we just sub accordingly lah. Okay, so you have what? 3 1 times 10 power 5 times 3, then you will get equals to, we basically want to find P2, then your V2 is 0.45. Okay, so you rearrange P2 equals to divided by 0.45, and hence at the end you're supposed to get 6.67 times 10 power 5. Question 13. Diagram 13 shows a displacement time graph for propagating along a piece of rope. Okay, what is the amplitude and period of the wave? So this is a displacement time graph. So what you can get from the y-axis, y-axis is always you can get amplitude. What is actually amplitude? Amplitude is the maximum displacement from equilibrium position. So simple idea, you have a pendulum, right? It moves to the highest position that time. Okay, so this is called amplitude. Okay, then what is time? Time taken is for this pendular example, you move up and then you move back down, you move to the other direction, right? So you move back. So it's one cycle, right? So initial, you are at rest at this position, example A, then you go to B, go to C. Okay. So for amplitude, no problem. You just get this, which is how much? 5 meter. But period is 1 cycle, which means you from 0, then you end at 1. Or you from crest, you end at the crest. You from trough, and at trough. So any 2 points which are in phase. Okay, so obviously our period is actually 1. Okay, so amplitude is 5. 5. So this one is not correct. And this one 1. So therefore, your correct choice will be C. 14. Which of the following diagrams show the correct refraction of wave from air to water? So as you all know, refraction of water wave occurs when there is a different depth in water. So when they are traveling from air to water, basically they will slow down, okay, from air to water. So if they slow down, that means they will refract towards normal first. So we look at which line is towards normal. So this one is away from normal. The dotted line is normal line. Okay, so either C or D. Then next context, you have to observe the wavelength also. Because they slow down by right, your wavelength should be decreases. So the wavelength is the distance between two consecutive points which are in phase. So it should be smaller. So that's why D is the accurate one. C cannot, because the gap is bigger. Notice. Okay, moving on. Diagram 15 shows the patterns of light produced in an experiment. So what is the phenomenon that involve? So this is the diffraction patterns when you actually shine the laser through a slit. Shine a laser through a slit. Yeah. So this is the result that you get. So it's diffraction. Okay. If it is interference, the fringes is kind of uniform. So if you have wider at the center and then towards the side it becomes smaller one, they are more towards diffraction. Okay, number 16 is under the idea on interference. Diagram 16 show young double slit produce interference pattern on the screen, and the distance between the consecutive red fringes is 5.6 mm. Calculate the wavelength of the red light. So of course, the formula that involved under interference of wavelength is this. Interference of wave is lambda equals to AX over D. Right? So they want you to calculate wavelength. So A is the distance between the slit, this A. Then X is actually distance between two consecutive bright fringes or dark fringes. So X is here. Then D is given already from the slit to the screen. Okay. Then when you want to sub, you next thing need to be alert is all of the quantity in the SI unit. You see they are in millimeter, So milli is actually 10 negative 3. So when you sub, you careful. 0.4 times 10 power negative 3. Then X 5.6 times 10 power negative 3. Then only divide by 3. And then you calculate, and then you supposedly get the answer. A is about 7.467 times 10 power negative 7 meter. Now, sometimes you're careful also, they can also give you the option answer as millimeter. In millimeter, then you have to change. So that's why you need to see the final unit also. Okay, but this context is in SI unit, so we already changed it, so no need to worry. Number 17, diagram 17 show a light from air refract when enter water and also perspect. Then they give you the refractive index for water and perspect, okay, respectively, which is 1.33 and 1.5. So they want you to get the angle theta. Okay, so as you all know, now we are not from air to another denser medium, we are from water to perspect. So memang there are two different medium. And if you all remember what you all learned in Snell's law, the formula involved is actually m1 sine theta 1 equals to n2 sine theta 2. So assuming everything in water is 1. So therefore, the refractive index for water will be N1 lah. Then this 50 is actually theta 1. While the theta here that what we want to calculate is I can refer it as theta 2 lah, or theta itself also doesn't matter, but perspect will be N2 lor. Okay, once you know the idea, then you can sub into the equation already. So therefore, I will have 1.33 sine 50 equals to 1.5 sine theta 2. My concept is to find the sine theta 2. So sine theta 2 is 1.33 sine 50 divided by 1.5. So hence theta 2 is what? You press calculator, shift sign, everything that you have here, after you calculate is by right is 0.6792 lah. Then you will get the answer in terms of angle of 42.78, which is D. Okay, number 18, diagram 18 show the image formed by a magnifying glass. Which of the following diagram is correct? Show the characteristic of the image formed. So it seems like magnified, right? Okay, then if you to notice, it seems upright as well, right? Yeah, so that means the characteristic of the image is by right, virtual, upright, and magnified. Okay, so to obtain the characteristic here, your distance of the object from the lens, right, supposed to be less than focal length. Okay, so object less than focal length, this one cannot, and then they are same size, ma. This one is at infinity already, so by right you cannot really see the image, because the image is enormous. Okay, and then for C, it's between F to F. It's supposed to be inverted. So again, it's not suitable. Yes, the idea is actually D. Okay, you see object less than focal length. Okay, then you have the upright and also magnified image. Number 19, which of the following diagram is not the application of concave mirror? Concave mirror. So concave mirror, again, when you place the object at different position, they will have different characteristic of the image form. So I always tell students the idea when the object, you have this boom, boom, rim, wrist, case, where V is virtual, R is real, and then U is upright, I is inverted, M magnified, same side, and then diminish. Okay, so if they are concave mirror, then they can always have all this characteristic. This one is for what? For concave mirror. And also for convex lens, similar final characteristic. But if they are convex mirror, then they always have one characteristic only, which is always virtual, upright, and diminished. So they don't want application of concave. Backup mirror dental, they will actually have the idea of magnified one. Yeah, so it's actually not correct. Reflector in car headlamp is actually parallel ray, whereby the object is at the focus point in front of the concave mirror also. But blind spot is the idea of convex mirror, because the image appear here is always diminished. Notice or not? Because they curve outward, those mirror. Okay, number 20 is from 4 topic, forces and motion under lift system. Diagram 20 show a passenger of mass 60 kg in a lift. Calculate the magnitude of the normal force when the lift moving upward with an acceleration of 1.5 meter per second. Okay, and giving you the gravitational acceleration is 9.81. Okay, so now they accelerate upward. Okay, so for lift system, police system, all these type of questions, right? You must always form an equation. So if you want to form equation, you must know what is the quantity involved. You have the normal reaction force upward, then weight downward, then acceleration, in this case, upward. So the concept of the formula is actually F net equals to ma. So net force idea is from here lah. So if your acceleration is upward, your net force is also upward. That means your normal reaction force supposed to be greater than the weight. So to form the equation, basically your idea is R minus weight is equals to MA. Okay, then the weight is also mg. So normal reaction force is actually mg plus ma. You have this equation one. Then you can actually substitute, you can factorize the mass as well, g plus a. Okay, then the mass is 60, then g is 9.81, a is 1.5. At the end, you're supposed to get the answer of C, 678.6 Newton. Or if let's say you all find this equation a bit hard to form, like you always confused. Okay, I always tell students, if you go up, that's mean against gravity, you'll find yourself heavier, apparent weight lah. Okay, but then let's say you have a case of downward, right? That's mean, wow, you suddenly forward. So it's like you will seems lighter one. If lighter, for case for this one, downward, R is mg minus ma. But if the object is at rest or move at constant velocity, then they will have the equal relationship. That means R equals to mg also, or your real weight as well. So whoever want to go slim down, you go inside lift lah, then you accelerate downward, okay? But it's just apparent. Okay. 21, diagram 21 shows a box is stationary on an inclined plane. Which of the following diagram present a free body diagram for the box? Okay, so for these questions, how do you rearrange all the three given force again? So I will tell students, you like playing the toothpicks like that. You can rearrange all the given force one, okay? You can reposition them again and then make it into a triangle, but you cannot change the angle of the force. Like my weight is down, so you see if I bring down here, then it's easy for you to see. Okay, so I actually get the idea already. Okay, so you will actually have your weight now on where? On the right hand side, left hand side, right hand side, sorry. And then this is your force, okay, and then the normal reaction force, I think I redraw with a different color as well, which is R. So I form a right angle already, correct? Okay, but in this case, they also involve the idea of angle, okay? So the angle of this 40 is here. So where is the 40 inside this triangle? So if you were to notice, it's easier for you to get this angle, right? This brown one is actually 50, then this 90 so your 40 is over here. Now, this is the first construction that I can have, okay? But that is not in the answer, right? So actually, you can also move your arrowhead, You see, teacher move the arrowhead again, I move my R to here now. Then F is here. So if I move this way, then your 40 will become where? The 40 become for bottom, right? Zigzag, get the idea? So this is 40. So you must be very careful on the location of the angle as well lah. Okay, so hence you're supposed to have the answer already. And then you see the arrowhead also, my weight is down, so it must be down. Like this case, up one tak boleh already. And then like my force is toward upward. So you see this one downward tak boleh. So basically the pattern A and B is correct one, but then the location of angle is also important. I say it's over bottom. So that's why the answer is B. Okay, so you have to try to sketch on the diagram. So then only you can find the angle easily. And for your understanding also, if you draw all the three given force, right, all the arrow is on the same direction. That means they are at rest, they are equilibrium. Let's say you solve some question, the arrow some sort look like this one, but then you have one arrow the other way around. Normally you put two. That means the object have resultant force. Actually, at the end, the object is moved at this direction with an acceleration. Just for your understanding lah. Okay, question 22, diagram 22, show a boy play a horse spring at the playground. What is the modification so that when the heavier kids, they want to support a greater load, greater weight lah. So if you want to support greater weight, what happened to the spring constant? They have to be high, lor. Oh, okay. So the idea of spring constant, I always tell students if it is high, that means it is hard to compress or stretch. Get the idea? So you can uh, uh, support a heavy object, ma. Okay. So basically, the answer here got two one. Okay, A and B actually can be acceptable. C is wrong lah because you will make the spring constant lower. Okay, but then increase the diameter of spring wire is a better choice. A and B also will be stiffer idea. Okay, but reduce diameter of spring is like unless you have more spring, so you can support lah, because it's also kind of you need a bigger surface area ma. But then by right, reduce diameter of spring is also increase the spring constant. It's also all these two memang they can cause higher spring constant. It's just that this context you increase the thickness of spring wire. By the way, for you to understand, diameter of spring, this one smaller, bigger. Then the diameter of spring wire means you have this thin wire and also thick wire. So this is a different for your understanding. Of course, B will be a more accurate answer lah. 23, diagram 23 show a fish is at a depth of 2.3 meter in an aquarium and the density of water is 1050. What is the pressure experienced by the fish caused by the water around? So you are actually finding the liquid pressure concept of H rho G. So what is the depth involved here? This is depth, and then we also have the density. Okay, and then G is always 9 points, so it's not a problem to just direct sub the value and calculate. So when you press calculator, you're supposed to get 23,691.15 also, which is the more accurate answer is C lah. 24, diagram 24 shows a hydraulic system for brake of a bicycle. So what is the physics principle involved? So a hydraulic system is always involves Pascal principle, where you generally they always will show you a bigger piston and smaller piston one, the idea. Okay, and then the concept is the pressure transmitted is transmitted equally. Okay, and hence you're causing the pressure on one of the piston is equals to the next piston, regardless of their surface area, and hence you have F1 over A1 equals to F2 over A2, and teacher will say small area, small force. Okay, big area, big force. So it's from Pascal principle lah. Okay, diagram 25.1 and 25.2 show identical shape. Identical shape tell you that they have same mass lah. Okay, in a winter water and also fresh water respectively. So which of the following statement is correct? Okay, so they are same shape, but then they are in different water, right? So if you were to notice in fresh water, there's submerged more. Notice this one, you still can see the brown color part. Okay, so more volume. The volume is increased. How come? Okay, so the idea behind it for this question, basically, there's much more is because the density of liquid fresh water is lower. This one, there's much less because the density of water is higher, winter water. Okay, but somehow because they are same object, right? So you have to have another concept under resultant force, whereby the idea of forces in equilibrium. both of them also will have buoyant force, and their buoyant force must also equal to their weight. So since these two objects have same mass, right, they by right should have same buoyant force. It's just that when you have this buoyant force idea, rho Vg, like for this context, since you have less than this density, that's why you need to display more liquid. Like this case, again, buoyant force equals to rho Vg. You have high density, so you need to display less liquid. But then, if both is floating, they're supposed to have same weight. Get the idea? Okay, so we see the option now. The weight of the window water displaced is greater than the weight of the fresh water displaced. Cannot, because the idea of weight is you need to involve mg the mass so then B, the weight of winter water displaced is the same as the weight of fresh water displaced. Yes, so this is the idea already, same. Then the displays of this one more or less also cannot one. Then the volume this one lagi tak boleh lah. This volume water is less this one more so the answer is B. Because the weight of liquid display is equals to buoyant force. Okay, next one, diagram 26. Show a graph of potential difference against current for conductor. What is the resistance of the conductor? So for graph of potential difference versus current, right? What quantity can you find? You can find resistance. So R equals to V over I. Okay, so you just take any point lah. Maybe you take this point, then the two coordinate, this one is 0, 0. And this one is 0.2 and 2.5. Okay, so 2.5 minus 0 over 0.2 lah. So you got right, get 12.5. Diagram 27 show arrangement of electric circuit. So what should you done to increase the reading of voltmeter? Okay, so you have rheostat here also. Okay, so basically, as you all know, generally the formula V equals to I. Now, of course, this question, they actually miss out an important statement. They actually have to mention also when I is constant is a better idea. So if let's say you always adjust the rheostat to make the current equal, then if this is constant, then we can see what is the relationship between the voltmeter reading and resistance reading. If current is constant, this means V is directly proportional to R. When resistance high, voltage voltmeter reading is high. So if you were to look at all these contexts, which one will cause a high resistance, increase the length, increase cross-sectional area wrong, lower resistance, right? Change the conductor wire to the copper wire also wrong, will cause a lower resistance. Okay, if you put two wire in parallel, you use the idea of 1 over R plus so you will cause the total resistance lower also. So the idea is A lah for this context. Okay. 28. Which of the following statement is not step in reducing the household electrical energy usage? This means you want to use less energy. Yes, by right, you're supposed to close all the window and door when you use aircon. Then off the appliances are not in use. Use a full load, okay, because you don't wash one by one. Now, use cost saver lamp is not a energy saving, cost saver, that means a cheaper lamp. So if cheaper lamp normally they are using filament bulb, those which need more energy. Nowadays good one but they are costly. Is like LED lamp, all this their price is expensive, but then long term they actually save energy. So the answer is D. Okay, 29. Show Fleming left-hand rule used to determine direction of force. So what is PQ? So your Fleming left or is always a standard or FBI. Or whether left hand or right hand, they are all refer to the same quantity. So F is the idea of force law. Okay, then B is the idea of magnetic field. I is the idea of current. So the answer is B. Next one, diagram 30 show a copper rod cut magnetic flux. Which of the following pair is correct to show the direction of induced current and also direction of the deflection of the galvanometer? Okay, now to get the idea on electromagnetic induction, you need to use Fleming right hand's rule, right hand now. So same thing, you have FBI, force, magnetic field, north to south, and then I is the current that being induced. We want to know where is our middle finger now. So your force is upward. Your force is upward, right? So your magnetic field is here. So remember, you see where is your middle finger is pointing towards you, right? If pointing towards you means this direction, right? P. So remember it's P. Okay. So when the current reach here, right, it will actually cause the galvanometer deflect to the left one. Okay, so therefore your answer is actually A. Okay. Now, if your current come from this side, then they will deflect this way. Oh, so this is the difference. Okay, yeah. Okay, 31, show an ideal transformer. So what is the output voltage? So they give you the input voltage and the primary turn, and then you have the secondary turn. So you want to know what is your output voltage. You are actually using the formula of Vp over Vs equals to Mp over Ns, whereby V is the voltage idea and is the number of turn of coils. But P is all referred to this side, primary, and then secondary is all referred to this side. Okay, hence you have 240 over Vs equals to 2000 over 500. Okay, so you rearrange, you will have Vs equals to 240 times 5 over 2, right? Then you get 60 volt. Or it's supposed to less than 240 volt because your turn is lesser. Okay, 32. Diagram 32 show an electric beams produced from the surface of a cathode ray. So name the process involved. They just say the produce on this cathode ray. So this process is also called thermionic emission. Thermionic emission is the release of electrons from a heated metal. When you heat up, the filament heat up, then you will release electron. Okay, so this process is called thermionic emission. 33. Diagram 33 show connections of a diode in a simple circuit. Which of the following statement is correct when the switch is on? Okay, so of course, this is actually diode, okay, whereby they're formed by p-n junction. So if there is extra hole, then you name them as p-type. If there are extra electron, you name that as n-type. If n connect to negative terminal, p connect to positive terminal, that means this connection is called forward bias. Forward bias means allow current to flow, right? Because the electron can drag across the depletion region and causing this depletion region, they will become thinner. When they become thinner, resistance is lower. Okay, so bulb is not light up, cannot. Reverse bias wrong. Getting larger wrong. Current flow, yes. So the answer is D. Next one. This diagram show a temperature control alarm circuit and the potential difference across XY must be less than 4.5 to turn the 6 volt power, the 6 volt bulb. What is the resistance of thermistor RT? So basically this is the potential divider circuit. And if you want to calculate, right, they have a specific formula one, okay, which is if I make it easier, I assume this RT the voltage across is 2. This one, the voltage across is V1. And then easier for me to show you 1 and 2. Also, the resistance here, I name it as R1 now lah. RT is equivalent to R2 as well lah. So the equation that you can use is called potential divider formula. Or you can have V1 equals to R1 over total resistance R1 plus R2 times total V. Or you can also use V2 equals to R2. Everything is same. It's just that if I'm using V1, the top resistance is R1. If I'm using V2, the top one is R2. R1 plus R2. If can, you all remember this formula lor. So any formula you can use, okay? Okay. Then next, of course, you also need to know the voltage across lah. So if your total voltage is 6, right? That's said already. You want it to light up. The resistance here, the voltage here is how much? 4.5. The V1 lah. Then of course, automatically 6 minus 4.5, you get 1.5 for this one. Okay? So now you can use any formula to get the answer lor. So assumption teacher use V1 or okay. If I use the idea on V1 one, so I already have V1 one, which is 4.5 equals to R1 20,000. You change the kilo to 1,000 lah. Okay, 10 power 3 Then 20,000 plus R2, whole thing times with 6. Then you simplify the equation up to you lah. This is your maths part already depending. Okay, so I normally will simplify over this side one so it becomes 0.75. Later I bring this whole thing lah. Then you type 20,000 plus R2 equals to 20,000. Then you will have 1,500 plus 0.75 R2 equals to 20,000. Then next you have 0.75 R2 equals to 5,000. So you get R2 how much? By using 5,000 divided by 0.75, and you get 66666 by 67. So it's actually about 6.7 kilo ohm. You don't change also can when you do substitution for this context. That means you remain 20 kilo lor. But because paper 2 sometimes students will ignore the kilo they didn't put. Actually, it's not correct. So because kilo is a value, you have to put inside the equation. So that's why teacher changed 2,000. 35. Which of the following equations show alpha decay? Okay, of course, you need to know what is alpha particles. Alpha particle is also helium nucleus, He42. So among the equation, which one showing that after the equation of He42, this one? Okay, this is gamma. So this is called gamma decay. This is actually beta. So this beta decay. A is actually a nuclear fission. 36. Okay. Diagram show a curve graph for a substance. So what is the activity of the sample after 30 minutes? Okay, so you want to get this idea, you need to know the half-life first. What is the half-life? Okay, so initial amount is 1,000. Half of it is 500. So you draw the horizontal line and vertical line, right? Okay, so it's supposed to be 6 minutes. So after how many half-life you will have become 30 minutes. So you can find out the n. N is 30 divided by 6. So you have 5 times of half-life. Okay, you can use the formula way. N equals to half n and naught. N naught is the initial amount. N is what you want to find out. So n equals to half bracket 5 times initial amount is 1,000. Okay, so you press calculator, you get 31.25. So you left this law. Or any of you think that you use arrowhead way is easier. That means 1,000, you go through one time, then 500. Go through half again, 250. Go through again, 125. Go through again is 62.5. Then one more time, right? 1 time, 2 time, 3 time, 4 time, 5 time. So you get 32 1.25. Again, same idea one. 37. Diagram 37 show a nuclear reactor between a radioactive substance. What is the type of the reaction? Okay, notice or not, you have this deuterium, tritium that combine, the idea of combine. So it's actually nuclear fusion. They fuse together. I will say, oh, union, oh, yes. Then they become a heavy nucleus at the same time. They release a neutron. What is the contribution of Albert Einstein in quantum physics? So actually, Albert Einstein, they actually introduced the concept of photon P. Okay, so for your understanding also, who introduced the concept of quantum? Quantum is come from this Max Planck. Okay, Max Planck. That's why when you do the calculation, you use the Planck constant. Remember, E equals to H frequency. It come from him lah. Okay, where energy is a discrete form, not continuous. Then line spectrum is from Niels Bohr. And who introduced the idea of this way nature of particle? This is Louis de Broglie. Okay, number 39. Which of the following statement is not characteristic of photoelectric effect? Again, not. So you're also careful during exam, read a yes or no or correct or wrong terms. Okay, so not the answer is A. Intensity affect the energy of the photon electron. So in quantum physics, they really focus whereby the energy of electron is affected by who? Affected by frequency. And then the rest is memang support photoelectric effect one. When the frequency is higher energy. The emission electron occurs instantaneously. The moment you shine on the metal, the electron straight away emitted. Then the minimum frequency that need to emit electron is called threshold frequency. Yeah, so all this support photoelectric effect lah, basically. Last questions, question 40. Calcium metal have a work function of 3 electron volt. What is the maximum kinetic energy possessed by the electron when it's irradiated with violet light? Okay, so for these questions, right, you need to know the Einstein, the photoelectric equation, which is the photon energy equals to work function plus max, K max. And then not only this idea, because your answer is in electron volt, right? And then part of the info here also in electron volt. So actually electron volt is another form of the energy in another unit lah. So you also need to know how to change the idea of joule to electron volt. Okay, so this one by right they're supposed to give here lah, or maybe that is in the formula list. So basically 1 EV is equals to how much? 1.6 times 10 power of negative 19 joule. Okay, and those equations show here, right? You can change their form one. Just like energy, sometimes you can change it to HF, like K max is can be half mv square. Or this one can be HF naught, okay? But then depends on scenario lah. And if they give you wavelength, you can further change this to become what? Okay, as you know, speed of light in vacuum equals to F lambda. So they be lambda can become C over F because C is a constant. So you can change another form again. Sorry, I want the frequency. Yeah, so you can have C over lambda as well. Here's C over lambda. So in this context, you remember need to change to this form. And then next thing, they remember give you the work function in W, so you need to change the pattern lah. And they want to find K max, so same thing you need to change. So I rearrange, I will have K max equals to work function minus HC over lambda. Your work function is 3. Then you need to minus a Planck constant 6.63 times 10 power negative 34. Then C is speed of light, which is also a constant 3 times 10 power 8. Then divide by, careful, your wavelength nano, right? Nano is negative 9. 3x0 times 10 power negative 9. Some more this, you see from EV to joule, you times, right? Joule to EV, you divide. this whole thing, you need to divide by 1.6 times 10 power of negative 19. Wow, macam complicated a bit, but you do all, then you only change this whole thing. So at the end, you have 3 minus, wait, actually teacher write the formula wrongly, sorry. It's supposed to be HCO lambda minus W. Okay, minus 3. I do the other way around. So you press. You're supposed to get this whole thing 3.27. I repeat again, this whole thing, when you calculate this, they are in joule. So you need to change joule to electron volt. So you divide. And then you're supposed to get 3.27. Actually, not so complicated. It's just that because they are in the unit of EV, right? Most of the students not familiar. You always use the unit joule. Okay. Yes. So you're done with the Sarawak paper. Okay. So that's it for the problem solving. So we will see again in another state paper. Bye bye.